Thank you everybody for coming out. I know the weather's been a bit frightful, but we got quite a delightful schedule for you guys today. Also, I know there's some first years from the winter intake coming to their first session here. I'd like to introduce myself. My name's Jack. I'll be the club president for the rest of the year, until April at least. And we got a full team of execs that you'll come to know and love, most of them at least. I know this session probably isn't the best one for the winter intakes because you guys didn't get to participate in the CTF. With that said, if you are feeling like you're missing out on the CTF, or if you did get a chance to participate in our CTF and kind of want to keep participating, no reason to stop now. If you go to ctftime.org, you'll see tons of CTFs because these are types of events are happening all throughout the year. A couple I'd like to shout out specifically is Magpie CTF, hosted by University of Calgary online. You don't have to go all the way to Alberta. Another great CTF made by students for students. I'm signed up. This will be my first time participating in Magpie. Why not make it yours as well? We also got Pico CTF. This one's a little further down the line in March, I think. But they got their challenges from previous competitions always available, and it's a great place to practice and learn. So with that said, back to the agenda. We'll be going through the CTF stats, and if you missed the announcement, we'll not just be announcing the top 100 users like we promised a couple weeks ago, but we'll also be announcing the write-up contest winners. So look forward to that. Afterwards, we'll be joined by some of our lovely CTF devs to do some walkthroughs for their challenges. So with that all out of the way, we're ready to get started with the news. Jess, you want to take it away?
Okay, well, good evening, everybody. So today's news story that I have for you comes from California, and this has to do with license plates. So California had become the third state after Arizona and Michigan in the US to allow for digital license plates to be used. And the company is called Reviver. So the company charges $20 to $25 per month for the service, and they claimed that the DMV certified cloud service backing the plates was entirely secure. So a team of security researchers were actually able to easily gain access to Reviver's system, revealing the real-time GPS location of all vehicles. The system uses a low-power LTE radio to remain connected to the company's servers, allowing users to change their plate's custom text or mark the vehicle as stolen. The researchers discovered that adding a new user to a target device is a two-step process that
You can keep going.
Okay, that requires the device name, certificate, and cloud ID from its local API. This was done, according to the researcher, by analyzing the HTTP traffic and seeing where the API traffic was routed. After creating an account, the team found that it was assigned a unique JSON object. So, JavaScript object notation, and it has these fields. And in one of those fields, they found that they were able to find out it had like an account type. And for the account type, it was actually listed as null to begin with. But by feeding it zeros and any number from 0 to 100, they were actually able to find different account types, with 0 being the Reviver role account type, which is essentially the admin role. And this allowed them to access all API calls, including the vehicle location. They could actually change the plate text, so your plate number, and most importantly, they could actually report your vehicle as stolen. The team disclosed the security role to Reviver, which, to its credit, patched the issue in 24 hours. And the next story is narrow.
Hey everyone. This next story is about a common infection vector that's used by some attackers to distribute malware, and that is through XLXLL files. These files are written in C or C++ and are a type of dynamic link library, or .dll, that can only be opened by Excel. XLL files allow third-party applications to add more functionality to Excel. And some malware campaigns distribute these malicious files via email or download sites, and when a user double clicks on an XLL file to open it, they will be shown a warning reading that add-ins might contain viruses or other security hazards, and are prompted to enable the add-in for the current session. If the target enables the add-in, it will begin to run malicious code in the background of their computer. And threat researchers first started to notice attackers using XLL files around 2017, but a surge in the use of this attack vector was observed in 2021. And currently, Microsoft is working on adding XLL add-in protection for Microsoft 365 customers by including automated blocking of all XLL files downloaded from the internet. And I'll pass it over to Patrick.
My article is how a hacker found FBI's no-fly list on an unsecured server. So the identities of hundreds of thousands of people were on an outdated version of the U.S. government's no-fly list and terrorist screening database were found on an open server. This was claimed by a 23-year-old Swiss hacker by the name of Mia Arson and Crime W. Over 1.5 million entries in the no-fly CSV file discovered by Crime W, including names and dates of birth of individuals on the FBI classifies as known as suspected terrorists, who are prohibited from boarding flights. Crime W pointed out the fact that these lists exclusively featured names that were of Arabic and Russian descent. This was roughly around like a million out of the 1.5 million people that were on the list. According to the hacker, Commute Air, an Ohio-based minor airline, maintained an insecure Amazon Web Service cloud server that included the no-fly list as well as confidential information of their employees, but they didn't find any information about the clients that boarded those airlines. According to Commute Air, the service was taken offline last week after it was discovered. This wasn't a targeted attack. The hacker was utilizing Shodan, a specialized search engine utilized by the cybersecurity industry to find servers that are accessible via the internet. And the next article will be by Singh.
Hi everybody. So my story this week is on a critical remote execution flaw that was found in Microsoft's Azure platform service, cloud platform service, that was exploited for complete control of users' applications who run their applications on the servers. The vulnerability is achieved through cross-site request forgery through Microsoft's Kudu service, a source control management service for applications. It's similar to cross-site scripting and is also known as by the names CSRF or session writing. It's a method where an attacker uses social engineering to trick victims into executing an exploit through clicking a disguised link via email or chat in the form of a clickable image while the user is authenticated on a web application. So it's very similar to cross-site scripting. Attackers can deploy malicious zip files and enable theft of sensitive data, and also make lateral movements into other parts of Azure services. The zip file is encoded in the body of an HTTP request, which navigates to the domain hosting the malware. Microsoft actually fixed the vulnerability in December and actually awarded a bug bounty of $30,000 for the find. The best way to minimize impact of an attack like this would be to basically effectively apply the principle of least privilege and limit the blast radius. And next story is Swami.
Hey guys. So the news article I'm bringing you guys is about Fortinet. So a suspected China-based hacker group exploited a flaw in Fortinet FortiOS SSL VPN. And through their vulnerability, this group targeted a government entity in Europe. The malware used in the attack is called Bold Move, which is written in C and supports both Windows and Linux systems. Once deployed, it receives commands from a command and control server, allowing attackers to perform file operations, relay traffic via the infected host, and spawn a remote shell. The extended Linux sample of the malware disables and manipulates logging features to avoid detection. For this specific attack on the government entity in Europe, the attackers exploited internet-facing devices used for security purposes and used a heap-based buffer overflow flaw in FortiOS SSL VPN to allow remote code execution. The attacks use the bold move backdoor malware, specifically the Linux variant, to run on Fortinet's FortiGate firewalls. That's it for the news.
All right, thank you, content team. Before we get started with the middle segment, also since there's a lot of first years attending this meeting, we're going to be putting an invite link in stream questions of the ISSessions Discord for the first year server. So feel free to join that if you're in first year. Great way to connect with your classmates and maybe get a little bit of help down the road. So moving on to our middle segment, we got the CTF stats as well as the announcement of some pretty exciting things. Let's open that bad boy up. There we go. Alright. So we'll be starting with some institution-based stats here from the previous ETF. We got quite a few attendees, 216 from a wide range of institutions in Ontario as well as abroad. Sheridan College, obviously coming out number one, the home team. Sheridan turnout was actually up quite a bit, so shout outs to you guys, especially the first years. Did a great job, no fear, signing up for their first CTF. Also, big shout outs to U of T and Ontario Tech. Pretty much no participants last year from there, but they came out en masse for this, even in person as well. A few debuts as well. I think Durham, Concordia also has participated for the first time. So great to see the way the CTF's been growing lately. Then we got some average solves. So Waterloo, not too surprisingly, leading the way. Our Sheridan stats, I think we'll get it up next year. Then we got some categories, and these ones are kind of interesting because you can kind of see how some colleges specialize in certain areas versus others. Like Seneca, absolutely dominant with the web challenges there. Waterloo also doing an impressive job. With the forensics, Waterloo again, Seneca again, and Fleming College really leading the pack there. We got our crypto, quite a popular category this time around. Waterloo, once again, leading the way there. Then with reversing, another pretty across-the-board one. Waterloo, leading the way. Fleming also with a respectable effort there. Poland, then you got Mohawk jumping off the ropes here. Really impressive effort. And OSINT, Fleming, for some reason, is really good at OSINT. Miscellaneous, Waterloo, blah, blah, blah. Yeah. Some interesting feedback. Vlad is amazing. We love you. And to whoever wrote the suggestion about the food, I promise the next team will definitely make sure there is some hot dog for you, since you asked so nicely. Also, as you can see, hopefully this will convince you guys to come out in person. The in-person was rated a bit higher, so be on the lookout for tickets next year. Challenge-based stats, I'm pretty sure we went over this during the CTF. Unicorns. So a unicorn challenge is a challenge which has been solved by just one person. We got a couple here. Ice Fishers, represented by Hadik. Sheridan, home team. He solved retro router ruse. Yeah. Actually, we're going to be doing a walkthrough on retro router ruse, so we might get a peek behind the curtain on how the magnificent Hadik solved that challenge. Also, shout outs to Abdul or Gigwam from Or Sleep 5, solving the Trend Micro challenge there. Connor, I don't think that's one of the ones we're presenting.
I don't remember which one that is, to be honest.
We love our sponsor, Trend Micro, but they could have done a better job naming the challenges. Alright, and then we have one unsolved challenge from the reversing category, not too surprising. What am I forgetting? We may never know. All right, now we're getting into some interesting stuff. As we promised during the CTF, we would release the top 100 users. This is including alumni, by the way. Just keep that in mind. I'm obviously not going to go through everybody here. I'm fine with going ahead of schedule, but it is on YouTube, so if you're trying to see yourself, you can just pause there. Seen quite a few first years again. There's the Cooler Jack at 71. Just going to keep moving on. All right, and we're approaching the top 10 here. So shout outs SK, Bravo 1, Noob B or Noob, I don't know, Sexy Education, Pixel, Murdoch, Kilimanjaro, I'm Pretty New, Soybean, and number 1, an absolute dominant performance from Strawhelm. All right, and this is the part I'm most excited for, because in security and also a lot of areas, it's not just about what you know, but also about how you present what you know. That's why we love to get write-ups afterwards, and this time we're actually turning it into a contest to try to encourage some. So thank you to everybody who submitted write-ups, but a special shout out to third place, Michael Nolk, second place, Ian Mann, and the winner of our CTF contest write-up is Nate Coolidge. So thank you again to everybody who submitted write-ups. Thank you again to our sponsors, and of course, thank you to everybody who participated in the CTF this year. We hope to see you guys next year. So with that, we'll be taking a break. We're quite ahead of schedule. We'll probably get started here, say, in another 5 minutes. So 7:25, we'll see you guys there. Oh yeah, and CCR. Again, we got a lot of first years, so let me just explain what CCR is real quick. CCR is a way to give yourself credit. It's kind of a record keeping track of ways you participated in Sheridan with extracurriculars, including ISSessions. Just kind of a way you can point to improve that you were an active member here. So Mason just posted the form in the Discord, stream questions, fill that out. When it asks for the CCR code or whatever, this is here on screen. This is the key. So do that, give yourself credit. If you get 20 hours by August, you'll be able to add ISSessions member. All right, and with that, we'll take 5 minutes and we'll be back. Good. All righty. I'm joined here by the magnificent Kyle. All right, we're ready to get started with our walkthroughs here. Kyle, our forensics guy, here to present some forensics challenges for you. Kyle, take it away.
Hello everyone, like Jack said, my name is Kyle. I was responsible for the forensic category. I hope you guys enjoyed the challenges. That was definitely my biggest fear with it. But today I'm gonna go over a few challenges that some of you have requested. And even if you never solved any of these challenges or just you got stuck on them, as long as you just learned something from it, that's really all I care about, and that's all we care about here at the CTF team, right? So the challenge I'm gonna go over is called middle of a memory, and I'll read the instructions to you. I don't have it up right now, but I'll just read it to you. So it goes, I got locked out of my computer and totally forgot the password. The only file I have is this weird DMP file. Maybe that could help me get my password back. So just by reading the instructions alone, we know that it involves getting some type of password back, right? That is our goal, is getting this user's password, right? But we're given a DMP file type, right? So a big part of the forensic category was doing a lot of research and just kind of gaining your own knowledge from it, right? So if you were to do some research on what that type of file is, it would reveal that it is a type of memory file, right? What you can gain from memory files is definitely a lot of data on the computer itself, including passwords as well, and just user data. We're just mostly worried about the credentials alone, right? But before we go ahead and solve this challenge, let's go and read the hint, all right? So the hint goes as follows. Benjamin Delpy loves cute cats. Okay, so who the hell is that? right? Who is Benjamin, my boy Benjamin, all right? So let's do some research. Let's type in his name. Benjamin Delpy, look at that. It's already auto doing it for me. Okay, so let's see what Google has to say about him, all right? So who is he? He's security researcher, cool. Okay, then we're getting a couple extra things as well, such as Mimikatz. Like, okay, what is Mimikatz? Proof of concept to show Microsoft that its authentication protocols were vulnerable to an attack. Okay, so Mimikatz sounds like a pretty powerful tool, right? What else can it do, right? Biggest thing it could do, where you can see, is getting account login information, right? And we're seeing even clear text of passwords stored in system memory. Perfect. So we have an idea of what we need to do now, and that is we need to use Mimikatz to read through this dump file and grab our password, right? So Mimikatz is available on his public GitHub repo, but just to save time here today and just we don't need to download anything and whatnot, I already do have it right here, okay? So we got Mimikatz right here. The only issue you're really gonna have with Mimikatz is when you're downloading it, Windows Defender is not gonna like it. So you just gotta have to kind of find a way around that, right? If I can do it, I'm sure many of you can, okay? So before we do run it, you gotta go and right click it and hit run as administrator. We're gonna go ahead and do that. Okay, bring this over here. So we're greeted with the front screen. Let me zoom in a little bit. Okay, does that look good, Jack? Yeah. Okay, perfect. Okay, so I'm just kind of going to go through these commands. I highly recommend that you look up Mimikatz and see what it is, what it can do, right? It's more than just passwords as well. You can definitely grab a lot of information from dump files, and you don't necessarily need to read it straight from a file. You can also just use it on the machine you're working with as well. So the first thing we're going to do is run a privilege command. Let's go ahead, type in privilege, debug, and then if we see it's set, okay, perfect, we got that set. And then next, what we need to do is we need to point to the dump file. So we're gonna go ahead and do that. Let me just go get that dump file. Perfect. So in order to point to that dump file, we're going to use this following command. Type in minidump, and then the location of where the file is. In this case, it's called file.dmp. This is the weird file already. So let's point to that. So we successfully pointed to that. And then it's as simple as running this command to get more access to it. So let's view some logon passwords. Let's see what's up here, right? And a lot of these commands, again, can just be gained through research alone, right? This is how I found out the commands, right? Super powerful tool. I highly, highly, highly recommend. Even if you didn't get this challenge, just look up at what Mimikatz can do, right? Okay, so we get a bunch of information. Let's start from the top, okay? So as you can see, just from this one command alone, and just from this dump file alone, we're getting usernames, we're getting domain, time, and whatnot, right? If we scroll down a bit, we can see that the password is null, but not to worry, is we do have an NTLM hash right here, right? If you do a little bit more research on Windows alone, this is essentially how it authenticates users when it logs in, right? And the whole point of Mimikatz and the creator behind it was to prove to Microsoft that, you know, your authentication can be broken, right? And let's just see if that is true, all right? So we're gonna go ahead and copy this NTLM hash, and we're just gonna use an available online hash cracker, right? This takes seconds to look up. It can honestly be anything. It doesn't have to be this website, right? So we're gonna go ahead and paste it in here and just, you know, tell the website, I am not a robot. We're gonna hit crack. And as we can see here, we get our flag, memory fun, all right? So it's really as simple as that. And the point of this challenge is I really wanted to point out just how vulnerable passwords can be, even on Windows. This was captured on Windows 10, right? Nothing too far behind, right? Windows 10 is still used, in a wide range of computers. It's still a very popular OS. Same with Windows 7, XP for a lot of machines as well too. And so you can just see like how simple a password can be and how easily someone can just gain this access to this type of information, right? Mimikatz is especially powerful when you combine it with the Metasploit framework, right? You can remote into a computer and then use Mimikatz to gain all the credentials without even having to like look through files and whatnot, right? You can just read the memory. It's an insanely powerful tool, and I highly recommend doing a little bit more research. But I hope you guys enjoyed that one. I do have one more challenge for you guys. Just give me 1 sec to get this set up for y'all. Okay. So let's read what this next challenge is. The challenge was called How Bizarre, and the instruction goes as follows. Hey Guts, I sent you a nice picture of us. Be sure to check it out. Oh, and don't tell Casca. She might get jealous. Love, Griffith. You guys get that reference? I found that funny. Hopefully you guys do too. But if you guys don't get the reference, it kind of sucks. Oh well. Let's look at the hint before we get started. So let's see, maybe that can help us a little bit. So it's telling us to pay attention to protocols. Okay, so let's keep that in mind. So someone sent us a nice picture, and it's telling us to pay attention to protocols. Okay, so the file that was included with the challenge was this PCAT file. And so essentially what a PCAT file is, a file just containing a bunch of network traffic, right, or packets. So let's open it. What we're going to use to open it is we're going to use a program called Wireshark, which is just used for network analysis, right? Again, another simple to kind of use program, but insanely powerful once you master it, right? So as you see, we have a whole bunch of just random garbage, right? Like, how am I going to sort through all of this? We're looking for a picture, but there's crazy amount of information here. Where do I even get started? So the easiest way, if you're going to analyze or you're looking for something in particular, if you want to go in order, then for sure you can definitely go and do that. But in this case, we're just looking for a particular file, right? Or in this case, an image. So what I recommend doing is go and click protocol and sort by protocol alone. That way we can kind of get a better understanding, right? So we go from the top, we're looking through all of this, and we come across this protocol here. Okay, let's read into a little bit more. So what we see here is we see a PNG image, like a file, an image file, and it's called Besties. Okay, so we got that. Even if we were to click it, it's just this jumbled mess. But we know that just from analyzing the network traffic that it was sent. So what can I do now? Well, this is another powerful part of Wireshark, where we can essentially take what was transmitted over the network, and we can grab it for ourselves, right? And to do that, we're going to go up here, click File. We're going to go to Export Objects, and pay attention to what protocol was used. In this case, it's SMB. Oh. So we're going to go ahead and click that, not misclick like I did. So we're going to click that. So boom. Okay, so we get an object list. So we only really need the PNG. We don't need this as well. So we're going to click this. We're going to hit save. Let's save it in this one right here. Okay. Perfect. So we saved it. We're going to go back to that directory. And as you can see here, we have a new image. Let's open it up. Look at that. What a beautiful picture of two best friends just hanging out. And it just so happens to have the flag as well. Besties for life. How cute. Alrighty. I hope you guys enjoyed these challenges. I didn't design them to be super, super hard. But even that being said, if you guys didn't get the challenges, like I said before, just as long as you learn something from it, that's all I care about. And I just hope you guys found this to be fun, but you know, you learned something at the same time. So now I'm going to pass it to, who am I passing it to? I'm passing it to our beloved Connor, who we love very much. He's going to show you a couple of his challenges. So stay tuned.
Oh, you do have a mouse, perfect. Okay. Ooh. They can't see this screen, right? The second one?
Anything on the laptop?
Cool, okay. Oh, we have a lot of stuff here. Okay. Hello, everybody. So my name is Connor. I'm a fourth year right now. So I actually just finished my 8-month co-op at Trend Micro, where I was working as a vulnerability research intern. And as part of that, I also developed a couple of the challenges for Trend Micro, as they were a sponsor this year. So the two that I'm going to be showing you are the two web challenges. It's not the command injection pwn one, or that really long like research CTFD question. So the first one, I believe it was we gave them very long names. I think it was ZDI can like 40024. It was with the movie DB website. If you took a look at that, I believe we have it open here. Yeah, so right now there's nothing on here anymore. Before it had pictures. They're not loaded anymore because the Imgur links are all dead at this point. We have them uploaded to Imgur. But this is what you'd be greeted with on the challenge. There would have been scrolling pictures going back and forth. Not super important. But as part of the challenge, you were also given access to this source code you can see here, which is this main.go. So I mean, you could have just taken a look through it. It's not particularly long, but if you look through, you'd see this thing down at the bottom. You'd actually see a link in this fmt.sprintf HTTP. So during the CTF, this 127.0.0.1 was actually an IP address. I changed it back, of course, because those IPs aren't live anymore, so I'm just hosting it locally. During the competition, this showed up as an actual IP. But, so if you see something like this, it's probably a good idea to go and investigate what's at this endpoint. So, I mean, let's just open this link. Let's see what happens in our Firefox. Oh, all right, it didn't work. I'm just going to type it in. And if we go to 2000. Okay, so we went to the link just very simply by reviewing source code. You know, we see this here. May as well go and investigate it. And it's actually calling this get movie endpoint. And if we see here, it looks like this, what we just went to, what we navigated to, it's actually printing us out a whole bunch of functionality. So this looks like it might be something along the lines of an API. And, you know, if you notice, there's actually this get flag. And there's this, if you see here, or I don't know how, okay, yeah, cool. Yeah, so if you see here, it's requiring, this little, what are these called, curly braces, means that this is like kind of like an argument, a parameter for, just with how Go websites work. But so if we try to go to get flag, 404 page not found. So that's probably because we need to supply what this API key is. From looking at it, it doesn't look like there's a way to get it here. But if we go back to the original source code, we can see it's calling this endpoint of /getMovie/%s. So I mean, as you probably know from doing all of our programming classes, this means that it's printing like a variable into this, which we can see as this ABC variable. So I mean, very simply, let's just try to find where ABC is in the code. It has to be declared somewhere. And if we look all the way at the top, we see this constant ABC string equals API key here. Just a string, so it means basically if we, my thing is lagging, sorry. So we know that this ABC variable just contains a string API key here. And then this URL we know is just going to be 127.0.0 get movie / API key here. So let's try to submit that as our API key. Woo, and look at that, we got a flag, hooray. So this is a pretty basic example, but it's very important that you do not hard code API keys. This happens all the time, or you see it in like a git commit, old commits, that kind of stuff. But it does happen that developers, they just forget, they leave their API keys in their code. Very, 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 very bad. Don't ever do this. Be very sure that you don't do stuff like this. It's always better, you want to have it stored in like a secure file. You would read from the file, so if somebody gets access to your source code, they don't have your keys. Cool. Okay, so that is challenge number 1. So once you submitted the flag for that one, you would get access to the challenge number 2 that I'm just pulling up here. So in this one, you would be given access to these 2 things from the player files, an API.go file and an initialize DB. So if we look at this API.go, so just from looking at this function here, this handle request, we can guess this is probably the source code for that API website that we were just looking at. It's printing out exactly what we just saw in these strings here. It's the same thing we saw on the website. So I mean, you could go through and just look at some source code of this just to try to understand what's going on. It's kind of self-explanatory just from looking at the function names. Return movies, get all movies. You can probably guess what these kinds of things are doing. Not overly complicated. Get all movies, order by, get flag. That one we know from before. Validate API, so that one we also know. Whoops. And I'm also just going to open up this initializeDB.go, as we were given this as well. So this, as you could probably guess from the file title, is just a script that's being run to initialize the database for this API. So it's just calling this add movie function a whole bunch of times. It's adding in names, an Imgur link. These Imgur links are dead now. What we also see down here is there's this line add flag where it's insert into flag values test flag for test here. So we can probably guess from this what we're trying to do is somewhere in the database and here there's actually going to be a flag for us that we need to try to figure out somehow from interacting with the website. In the code we were given, the flag was obviously removed. We're just given this code so we can kind of understand what's going on the back end. But so from looking at this, we can kind of determine that our end goal is to figure out what value was put into this flag table or flag database. Everything else in here is pretty straightforward. If you take a look through it, it's basically just adding stuff to the DB, not overly complicated. Okay, so if we go back and look at the API.go thing, you can just do some code review, just try to look at stuff. We can see there's a lot of SQL stuff going on here. We saw that was initialized DB. It's a safe guess to probably assume this is going to be a SQL injection of some kind, if you go in with that idea. And you would not be wrong if you assumed that. So as for determining the vulnerability, sometimes it can just be a knowledge thing. With this example, I believe actually the hint was to try to look for something that's being done a little bit differently in one place than it is in others. So if we see in, for example, this get one movie. So this line here, select star from movies where name equals question mark. Okay, let's try to look at the other ones. So this one, okay, interesting. So this one is doing it a little bit different. Instead, it's doing select star from movies order by %s with decoded order. So it's doing it with this %s instead of this question mark. So maybe that's something we should look into. And if we look up, there's actually another place where it's also doing this same kind of idea with the, with the select star from movies. So if you do a little bit of research, you'd see that this style basically of doing a SQL command is the safe way to do it, because it's going to treat this movie name as a string and it's just going to keep it in a string form. But this way down here, this is actually unsafe, because the way that it's doing this is it's actually just straight, basically like a string concatenation is the way you could look at it, where it's just adding in whatever is in decoded order. It puts it just right beside all of this stuff here with no validation, nothing like that. So SQL injection, very straightforward. Some of this stuff, if you've done SQL injection before, this kind of stuff, you can notice it very quickly. If you don't know what SQL injection is, don't worry about it. It's not a big deal. It's not overly complicated. It's a very cool topic. It's one of the big reasons why I actually got into security. I had a class in in my previous software engineering degree, and we started learning about SQL injection. I thought it's just the most ridiculous scenario. It's the most ridiculous concept that you're literally just typing in SQL commands to a SQL statement and getting stuff to run arbitrarily. It's really cool. So we know that there's a SQL injection here, but what can we actually do with this? A lot of SQL injection challenges you might see, maybe it's like a login page and you're trying to type in a username and a password, and you might try to do something like a quotation mark or 1 = 1, that kind of stuff. So you're bypassing a true or false statement. With this one, it's not a login screen, and it's not we can't, with this SQL syntax, we can't actually just execute arbitrary commands. We couldn't just type in, print me the flag from this thing. Because you have to do something that's syntactically correct with SQL. And with how this is set up, this select star, we can't just type in whatever we want. We have to do something that actually works. So how the vulnerability for this is what's actually called a blind SQL injection. So it's a little bit of a more advanced topic, but the idea basically goes is when you can't actually see directly the result of your SQL statement, but you can see a true or a false return value from it. And by doing that, you can sort of start to piece stuff together piece by piece. So with this is actually a very common thing you'll see is if you see SQL injection and you see order by, 99% chance it's going to be a blind SQL injection, and it's basically the same format you'd see anytime. But so what we can kind of try to think about is if we're able to inject into here, we can run checks to enumerate the letters of the value from that flag database one by one until we've basically gotten the whole password or the whole flag that exists inside of it. So I'm actually just going to pull up so I can show you a little bit more. Oops. Okie dokie. So some of this stuff, it does require a little bit of knowledge of how SQL works and some kind of stuff that you need to know ahead of time. So what I have here is this is just a request I captured with Burp Suite of that order by ID API, the one that we were looking at with the So it basically just captured a request to this get all movies order by. So just by looking at the source code, we see the decoded order, and just from reading this stuff, we know that the parameter that we're trying to inject into is that order parameter, which a normal request, we could, just by looking at it, we see there's this ID here. So if we send this request, we see it's returning us a list of all of the movies in the database sorted by the ID. If we change this to name, if we change this to the name, now it's returning them in, in order, alphabetical order of the name. So what we can try to do is, I'm just going to paste this in and explain what's kind of going on here, because it's a little bit out of the scope of this, I think, to explain exactly how a blind SQL works. I think it might take a little bit too long. But so essentially what's going on here is SQL supports this syntax called case one. It's basically like an if statement, not really much difference. So what is, just gonna expand this so it's a little more clear. Okay, so the stuff that we typed in is all of this. So this is what we're trying to send into that SQL statement that's going on. So we're saying case when substring. So substring is just taking a one or it's taking an amount of letters from any sort of string that's in the database, depending on how many you specify. In our case, we're specifying, this means that we're taking the first letter, and we're only taking one letter, is what this 1, 1 means. So this command here is we're just selecting flag here from flag, which just by looking at that initialize DB file, we know that flag here is the column from the flag table, and that's what we're trying to enumerate. So basically, this whole line here, all this is doing is saying select the first letter from the flag here of the flag table. That's all that's doing. And then we're just checking to see if this is equal to A. So we say if the first letter of the flag here from flag is equal to A, then ID, else name. So basically, this whole statement is going to go, it's going to say, okay, so if the first letter of the flag here from flag is A, then we want to order by the ID. If it's anything else, then we order by name. So we know that the first letter is going to be RetroCTF, so we know the first letter is actually R. And I need to URL encode this. All I did there, I just pressed Control U to URL encode just so it understands it properly. Okay, so how did this return it? So this returned it in order of names, right? Not by ID. So by that logic, we know because it returned it in order of names, we know that the first letter is not A. And just to prove that that's how it works, if we do B, it should return it the same way. C should return it the same way. What happens if we do R? Look at that. So we changed it to C if the first letter is R, and now it's returning it in order of the ID. So it's returning it differently. Using this technique, you can use Burp Suite to go through and enumerate it character by character. It takes a little bit of time using the free version because they actually rate limit it, which is very annoying. You can write a Python script that goes through, but using this kind of logic, you can basically just write a script that you would just say, okay, is the first letter A? Is it B? Is it C? Is it D? Blah, 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 until you find the first letter. Then you move to the second letter. Is the second letter A? Is it B? Is it C? And you can just go through over and over until you have determined what every single character of the password, of the flag here is. That's basically how you would actually go about solving this. I'm not going to go through that because it would take too long, the actual stuff. One tip that I would highly recommend when you're doing SQL injection challenges, especially if it's like an actual web thing, and it's actually, I guess it's not actually unique to SQL stuff, but the idea of sandboxing. When you have access to source code, or when you're trying to get something working on like a website, there's a lot of stuff that can go wrong other than your syntax. So you want to be absolutely sure that the injection you're sending, assuming there's no external factors, that it works. So the easiest way to do that is, we have access to the source code of that API, right? We can api.go. So we know in the source code what we're trying to inject into is select star from movies, order by %s. So we know that this part is 100% in the SQL statement when it runs. And then all of our injection stuff is going to come after this. And it's happened to me all the time where I'll have a little small syntax error with my SQL injection or with whatever I'm trying to do. And I think that it's something going wrong with the web server and that's why my payload isn't working. But as it turns out, I just left out a bracket or I left out a semicolon. I forgot how case 1 actually works. So the easiest way to make sure that your syntax is 100% correct, just spawn a terminal. Just type your stuff into an actual SQL terminal. Make sure that it works 100% the way it's supposed to, then try to go and make sure that there's nothing funky going on with the website itself. And this is super applicable to anything where you're doing code review or you're actually analyzing code. It's very, very, very helpful because there's a lot of stuff there's these little intricacies. Functions don't work the way you expect them to, or stuff like null bytes and you're forgetting little one-off in loops, or you're forgetting one-off with how the length of your payload. It's really, really valuable to do this stuff, even if it's like a C program. Just go online C compiler, type your stuff in. Make sure you 100% know what's going on and what it's printing, what everything contains, before you try to think of other stuff. Yeah, I think that's it for me. I will pass it off to Reed. Thank you so much, guys.
Chris's challenge?
It's desktop walkthroughs.
Where's that?
Oh, on the VM. Your stuff is here.
Sweet.
Okay. So, this is one of the crypto challenges designed by Mr. Christopher Hyde. So I'm going to be walking through it in his stead. So, for this challenge, prerequisite, you do need to have a certain amount of understanding of the RSA. Because if we open up the text that you get 3 numbers, that's it. In the hints for the challenge, you get some Python libraries, which kind of gives you a hint that, that you're going to need to use code. Also, these numbers are quite long, so you can't just kind of go through it. You actually have to, properly use Python. So, the Python code that he has here. Yeah, so here is the actual solution code for how to solve the challenge. I'm going to walk you guys through what it does. First though, with the RSA, we're given 3 numbers here, C, N, and E. C is the ciphertext, so that's kind of what you're trying to decrypt. N is this really big long number, and E is the exponent that you encrypt everything with. E, the exponent, is used to encrypt. One of the things that we need is a decryption exponent. Now, how do we get that?
I don't know.
You don't know? You're in my crypto class, you should. To get the decryption exponent, step 1, you need to factor n to get p and q. So right up here, this function right here, it's the first one called in main. You input n, and you use this to, so this is used to factor. So step 1, factoring n will give you 2 prime numbers, but given how long n is, you need a little bit of a hint for how to get started. The title of this challenge is Weak RSA. If you do a little bit of research about the RSA crypto system, and kind of understand the actual math behind it, one of the really big things that's important is that P and Q, the 2 numbers that when you multiply them together create n, they have to be far apart. The numbers are big, but if they're too close, that can make the crypto system quite vulnerable. One of the rules with the RSA, if you take the square root of n, one of the factors is going to be below n, or below the square root, and one of them will be above. So the first function that is run here, you get t, or you calculate t, which is the square root of n. That basically serves as a midpoint. Chris then calls these 2 functions. They are given as hints for the challenge, but you'll see that they're imported up at the top here in this library. So if we scroll back down, we look at the top, or the next prime and the previous prime. Basically, you look for the 2 primes on either side of n, and those will be p and q. Hence why you want those 2 primes to be far enough apart. So once you have p and q, you can then solve for the totient, or in this case, it's denoted as phi. So yeah, that's just a straight calculation right here. once you have P and Q. And next, we're solving for the decryption function. Let's scroll up. Yeah, so here. So once you have the totient, or phi, you can then use that and the encryption exponent that we were given, that was provided, and you solve for the inverse. Once again, this is provided in the crypto library, given in the hint, and you can now solve for D, the decryption exponent. So the RSA is very secure when done correctly, but with these little kind of intricacies, if it's not set up right, it does a good job of punching a hole in your crypto system. So as you see here, we've solved for D, or the decryption exponent, and then you can just straight up put it into a function to decrypt it with the ciphertext right here, the decryption exponent, and N. Yeah, so then decrypt is up here. Yeah, so here with C, D, and N, you just you use the power function using N as a modulus, and that'll decipher it. Okay. Can I run it from here? Come here, boy.
This man doesn't know how to CD.
Nah, you do it. I don't want to play with your team.
You usually do. Alright, CD. We're doing RSA, yeah?
Yeah, RSA.
Alright, Python 3, solution.py. You were locked and loaded, man. Do the honors.
Thank you, sir. So actually running the code that was provided, it shows right here the square root of n, still a massive number, but by using the provided library, you've solved for the first prime, which is here, and the second prime, which is here. One thing that is worth noting, even though these numbers are extremely long, if you look at the last 4 digits of each prime, P and Q, you'll notice that it's all the same except for the last 4. So that's how close they are. It's only that last bit that's different, and that is kind of the big thing that punched a hole in the crypto system. So once you have those, you can then decipher it. This is all in bytes, and then turning that back to a human readable format, we get this. So that is Chris's challenge. Next, I'll go over one of mine. So for my challenge, this one also involves some number theory. It provides you with 4 different encoded pieces of information. You have the first key, second key, these symbols right here, the little uptick thing, this denotes that these 2 values have been XORed together. There are a few different kind of XOR properties that are denoted in the instructions for the challenge. We don't have those here though. That is fine though. When you're XORing things together, the order doesn't matter. The order that you XOR things doesn't matter, and the order of operations doesn't matter either. So effectively, give me a sec. if we look at the code to actually solve the XOR challenge, you only need 3 of the 4 provided pieces of information. You need the first key, and this is one of the other keys, but it's the third key and the second key XORed together. The flag has all of the keys XORed in with it, and because the order of operations doesn't matter and the order that you XOR things doesn't matter either, in one statement you can XOR all keys, because this one here has 2 and 3 in one kind of package, and the first key, you can XOR all that together with the flag, and it will give you the result. And there it is. So by XORing all of those together, it prompts you with the flag. So
Next up is
number 3.
Mark joining us from the internet. I'm just going to mute on my end so we don't get some echoes. So Mark, whenever you're ready, just share your screen and I'll send you a message when we're good to go here.
Yo, how's my mic? Yo, testing. Just let me know if my mic's good. Can the guys in the auditorium hear me? Alright, so my name's Mark. I made some of the web challenges. I'm gonna be walking through the forging challenge and the router ruse challenge, which is one person solved it, so I have to go over that now. Show you guys how to do it. So I made a little PowerPoint presentation here to demonstrate what's going to happen. So for the Flask cookie forging, the hint was Flask cookies can be tampered with. The goal is to change the auth to admin. Let's just begin right here. First we have to do is enter cream, as the word says here. If you don't enter it, you will get something called not quite right. So enter cream, and it says you're getting somewhere. Now, what happens is that if you have some type of cookie editor, a cookie is established. I'll show you what happens if you don't enter the correct one. There's currently nothing important in the session right now. Enter cream. And a good way to see what this gives is to go to a website called jwt.io to translate what the cookie means. So right now it means auth cream. Right here. Your goal is to change cream to admin. So you have to forge a cookie to say admin. So how did I make this vulnerable to forging? Well, one of the main reasons why is because of the secret key here. The main reason we're able to modify that because the secret key, which is used to encrypt a cookie's data, is vulnerable, which it should always be kept a secret right here. But I give it to you guys. So begin. So the tools you'll need for this is Sewell, Flask Unsign, and a cookie editor like this one here. So let's begin first with how to start this. So Sewell makes word lists for website. I'll begin by making a word list this entire website right here. Now let's read this word list, and it makes a bunch of little words like this, single strings. So what we're gonna do is brute force our way in to find the secret key, which could be any of these. Sprinkles, cream, sandwich, like that. So by finding that, I have a chance to modify the cookie. Now we will get the cookie from here. Let's put it into a file called sudo nano cookie.txt. We just paste it in. Delete this. So the new cookie will be this. Control X and then Y to save and enter. So now my cookie will look like this. Now the next tool we're going to use is called Flask Unsign. So what Flask Unsign is, it's basically a brute forcer. This is an example how it is. So command line to fetch, decode, brute force, and craft session cookies of a Flask application by guessing secret keys. Basically what it is. So the command that we're going to use is called Flask. Just sudo just in case. Flask unsign. So we have to first unsign it. Cookie. And we're going to use the cookie.txt we made. Let's put the word list here. So what this is going to do is decode that whole thing. We're going to get the secret key of biscuit. Now, this should never be publicly given to anyone because they can get access to your website. Now we have to forge a cookie with that. Flask unsign again. I'm going to sign it this time with a cookie. And this is important. We don't mess up the formatting here. Secret as biscuit. So this did is make fake cookie or a real cookie. I'm gonna translate here. It's gonna say auth admin. Now we go back to the cookie editor we paste it, save it, and then refresh the page, and then we get our flag. So John Hammond has a really good video to watch if you guys want to learn more about how to forge Flask cookies. And just anything in general is pretty good at this stuff. So that's it for the forge. Any questions in chat? Just let me know. Next is the hardest one, the harder one I mean. It's a HTML host header injection. Let me get this set up real quick. I'm just making the Docker right now to run it on my local machine. There we go. Hey, stop messaging me. All right, so this is the inject challenge here. Let's go over it. So the hint is there's a hidden page. The hint is provided, the description as well. The server has automated scripts to reset the password and you get the token. So website, welcome, want to apply for an admin role. Here are the credentials. So we have to basically put this in a notepad here so we don't lose it. Or just makes it easier for us to access. This was our credentials. We got attacked. Not sure if it still exists. Maybe the login or register has something for you. All right, so we see only one button here. We click it. We go to the pager. Let's enter our credentials. Fairness school 1, 2, 3, 4. We log in. We get an error. So let's go back to our description here and our hint to see what we have to do. There's a hidden page. Hints provided description as well. All right, so with that hint, we can see here that maybe the login or register has something for you. So we can try to change this to the register path. And look, we see we found a different page here. Please fill in the field below with the same email. So we're going to attempt to change the password and the email that we've given, or anything to be honest. It'll work. Register here. Another error has occurred. Something has changed. Let's check the login screen. So find your way back to login. And then see something different here. Forgot your password. So try clicking that. Here we see a very important page. Now we come back to the hint. So the server has automated scripts to reset the password. How can I get the token? Now we will be using these three tools, Burp Suite, ngrok, and Python. I'll be explaining what each of them do. So we get started on Burp Suite first. Open up Kali Linux here, type in Burp Suite. So what Burp Suite does is that it's a collection of tools for web testing. Let's go to our proxy here. So what this does is it basically catches the request and makes it so we can edit things and do whatever you want, basically. So let me open up this. So I used something called Foxy Proxy to help me with the interception here. So let's send in our stuff to admin. Share to college. Let's see. Reset the password. Nothing happened because I didn't click the burp. So now we see here the request. So what's this is basically done is that it's sent a token to this email. But the thing is, we don't have access to that email. So we have to find a way to basically intercept that and make it so it sends it to us. So we'll be using now ngrok and Python to do that. Let me just get this two set up. Let's open these two terminals. That one. Let's get two terminals here side by side. We don't need that. So command I'll be using, I put it here. The solutions. Pretty big solution, so overwhelm yourself reading all that. Let's use this command right here. python/m. What this does is it makes a local web server at this port. So that's what it does. And what ngrok does is that it makes it so I can basically make this global. It's a good way of testing things really quick. So it's like its own website. I'm just gonna pull this away because I put a password for it. Because people can actually get access to your computer. Kind of funny, but a bunch of gibberish, right? So we're greeted with the screen here. This is basically my own website, just connected to this. So what we're going to do is try and copy that forwarding, go back to our host here. We're going to do the host injection right here, right now. So I'm going to forward this. Wait, hold on. Hold on. Supposed to work. Give me a sec. A bit of a malfunction here. Let's go run this. All right. So what I did was I clicked forward over there and it basically caught this get request here. Let me stop and the intercept here. What it did was catch the get request, which contains the token. So I basically intercepted the token request that was sent to the email and got sent back to me. What I'm going to do now is change this. I don't need this anymore. Let me just close all this. Now I got the token. This is all I want. I click enter here and I get a different page. So by coming to this page, we basically solved the hardest part of the challenge. Is basically getting the host header interjection done. There's still quite a bit more to do, but let's just make a new password. So I'm going to do 1234 and a password. And we get another questionable thing here. It says the flag is here, but not actually here. So what do we do now? The only logical thing to do is go back to burp, or you can do some inspect right here, which is not going to help too much, but I'm going to do. Now I'm going to refresh this page while the intercept's on and my proxy's on burp. So I will now send this to the repeater. What the repeater does is that it makes it so I can basically manually test and modify individual HTTP requests and responses. Now we're here. We're going to send this, and then we're greeted with the flag. and the HTML. That's basically how you do it. Challenge. I know it's not that easy, but if you want more of a text solution, there you go. And for some useful resources I used for making these challenges was Portsrigger, TryHackMe, This Guy's a Legend, John Hammond. And we got Rana Khalil, who does the Portsrigger walkthroughs. Portsrigger is just like labs for web vulnerabilities. That's it. Dunzo.
All right, thank you, Mark. Thank you, Kyle, Connor, and Reed. Thank you all to our CTF devs for not just doing those presentations, but making the CTF possible. Hopefully you guys learned a thing or two about some of the challenges you might see in the wild there. I've said it a million times, and I'll say it another million times. The way you get good at CTFs is by doing CTFs. So basically, don't be afraid to learn. Give yourself a chance. Speaking of learning, which PowerPoint do I want to open up? Yeah, this one. Our next session is, that's not the one I want to open up. Our next session is February 9th, so I hope to see you guys there. Until then, have a good night and take it easy.